we know how to name an acid, we're ready to actually look at a neutralization reaction. So just like we did with the precipitation reactions, we're going to want to look at the reaction mechanism that's occurring here. And so if I've got lithium hydroxide, if I've got this guy in solution, it's going to look like this. I'm going to have lithium plus over here. I'm going to have OH minus over here. That oxygen is going to have those extra electrons there. And then I'm going to have an HCl. And when these react, what's really going to happen is this oxygen, these 2 electrons from this oxygen, are going to reach out and grab that hydrogen. That hydrogen is going to let go of its bond with the chlorine. So we want to draw these arrows from our electron pair, to the thing we're napping. And so after that, what's going to happen? Well, that oxygen is then going to be bonded to that hydrogen, and that chlorine is going to be all alone. So we're going to have Li plus here, and then we're going to have the oxygen bonded to the 2 hydrogens, and then the Cl minus over by itself, having this full octet. And so what we end up with is we have water. We end up with water here, H2O, plus LiCl, lithium chloride. And that lithium chloride is going to be in solution. It's going to be an aqueous solution. If I were to evaporate off that water, I would be left with lithium chloride crystals. So any acid-base neutralization is really going to follow that. The business end here is really the hydroxide and the hydrogen cation. So let's look at another one. All right, how about this reaction? My sodium and my hydroxide in the solution, those are going to break apart. Just like before. Okay, and then I've got my HNO3. What would that look like? Well, I would have that N to O, I would have those 3 bonds, and one of them would be attached to a hydrogen. The other 2 bonds here would be resonating, but we're not going to concern ourselves too much with that. We're more focused on making sure that we draw out this hydrogen right here correctly. And so once again, the electron pair here is going to come and grab that hydrogen. That hydrogen is going to let go of that bond, and those 2 electrons are both going to belong to that oxygen right there. And so what I end up with is I've got an Na+, I've got H2O, and I've got an NO3. And so that's my outcome of this reaction. I've got an H2O plus an NO3 in aqueous solution. So my neutralization reactions, hopefully you can see this pattern, we're always going to make a water. We're always going to make one water, and then we're going to make some kind of ionic salt. Okay? So we're going to make a water and an ionic salt. Let's look at another one. All right, in this one we should be able to draw out that mechanism. I've got my K+, got my OH minus, and then I'm going to have my hydroiodic acid. And so my oxygen is once again going to grab that hydrogen, and that bond is going to go to the iodine. And I'm left with water, K+, and I minus. And so I end up with H2O plus Ki. Let's look at one that's going to be a little more complex, one that's going to actually require some balancing. If we draw our mechanism here, we're going to have an Na+, just like we always do. This ionizes in solution, so it's going to be broken up in Na+ and hydroxide. And then we're going to have the H2SO4. Let's take some time to draw that out. All right, so we can see my hydroxide here. This is going to grab this hydrogen. That hydrogen is going to let go of that bond. But then I would be left with an HSO4. So I can see just grabbing one hydrogen is not going to be enough. I'm going to need another hydroxide here. And if I bring another hydroxide, I'm going to need to bring another sodium. So right off the bat, I can see I'm going to get 2 sodium hydroxides. Okay, so then this mechanism goes. It's going to grab that hydrogen. Hydrogen gives up its bond with the oxygen. What am I left with? Well, I'm left with 2 waters. I'm left with 2 waters, 2 sodiums, and a single sulfate. And so I can just write that in here. I'm going to have 2 H2O plus Na2 SO4. That's going to be aqueous. H2O, what's that going to be? That's going to be liquid, obviously. Great. So at this point, we should be able to practice drawing out these mechanisms, and we should be able to predict and balance a neutralization reaction. Because all we're going to have is we're going to make H2O, and then anything left over, anything that wasn't involved in the H2O, which is H2O, that was involved, and that was involved. So the leftover, the Na and the SO4, those just get together. So we just put those together on the other side, and then we're done. That's it.